Okay, hello. So we are doing 5.4, which is multiplying and dividing rational functions. So remember, rational functions means some kind of fractional function going on here, where we have something in the numerator and then something in the denominator. So when we're trying to multiply and divide them, we're also working a lot with simplifying them. So I'm going to show you a little example of simplifying first, and then what we're going to kind of need a little bit of background on, or maybe a little refresher in order to keep working forward. So what we want to do is be able to, after multiplying and dividing, simplify. So we'll start first with simplifying. If I had the fraction 15 over 65, what I would ask you here is this fraction simplifiable? Meaning, can I reduce this fraction in any way that it's going to be smaller numbers here instead of 15 and 65? So what I would expect you to say is, yeah, I think so, for sure. But then I would ask, well, how can you do that? Hopefully you can see that both of these can be divided, or F5 can be taken out of them. Specifically, 15 is 5 times 3, and then, sorry, let me fix this really quick. And then for 65, 65 is 13 times 5, or 5 times 13. So what's happening here is I'm separating the common thing from the not so common thing to be able to say if they both have a 5 in them, that can cancel. And the fraction here left over is 3 over 13. So this is what we're going to be getting into. And this is a very low level example of showing you that's how you simplify a normal fraction. So this thought process is not going to be incredibly new to you. It's something that you're kind of already doing, just with some variables involved in it. So looking forward, we can have 4 times x minus 3 over x plus 5 times x minus 3. And what I'm seeing is like, ooh, that's canceling. That's nice. I can cancel those two things out, and then I'm left with 4 over x plus 5. Only you're not going to see them in as simple terms as this. What you will see is 4x minus 12 over x squared times, plus 2x minus 15. That is what you will see instead, okay? So we have to be thinking about, how do I take it from this version that's not obviously simplifiable over to this version that is easily simplifiable? Okay, sorry, I gotta check my battery life quick on this computer. Okay, I'm good. Okay, sorry about that. So after after being able to get from here to here, it's awesome, it's easy to simplify. But I need to figure out, how do you get from this place to this place? So that is called factoring, which I'm sure we all need a nice little reminder of how to do. So we're going to do some factoring. We'll factoring boot camp as a refresher. So if we have x squared plus 8x plus 12, I would want to be able to factor this by taking, when it's in this form of two variables within the same function and a third term without one, what we do is we say, well, is there any numbers that in which can multiply to 12 but add to 8? So what I'm thinking here is, well, let me find factors of 12. Factors of 12 are 1 in itself, 3 and 4, 2 and 6, and that's it. So out of these factors, they all multiply to 12. Which ones will add to 8? Those numbers are 2 and 6. So we would set this up to be x plus something or minus something times x plus something or minus something. The numbers that go here are the two numbers that you choose. So I could write this plus 6 or plus 2, or I could have it plus 2 plus 6. That order is not going to matter here. What's important is that your signage is correct. I'm going to grab my chart real quick. Super sorry about that. It's giving me the battery sign now. I think my battery's going out on this thing. Okay. So let's do some more factoring techniques. One more example of that, let's do. X squared, let's see. Plus 8x plus 16. And okay, that would work. And this one. Okay, so with this top one, what we want to do again, two numbers that multiply to 16, add to 8. Or factors of 16, 1 and 16, 2 and 8, 4 and 4. Out of those factors, which ones add to 8? It's going to be 4 and 4. So x plus 4, x plus 4. In the next example, we have a negative coming into this one. Negatives are okay, we can deal with them. We just have to incorporate them into our thought process. So again, factors of 15, 1 and 15, 3 and 5. So out of these, I have to say, well, which one can I get to manipulate to 3? Did I do this one wrong? Sorry, just 1 second. Shoot, this should be. This should be a 2. Sorry about that. Totally confused you there. Negative 15 and positive 2. I thought I wrote this right. So if I want to get to have a positive 2, out of this, could I have, would negative 1 plus positive 15 get me there? No. Negative 15 plus positive 1? No. So this 3 and 5 is what I'm going to focus on. One of them has to be negative in order to multiply to a negative 15. Which one it is important because it also has to add to positive 2. If I have a positive 3 and a negative 5, those multiply to negative 15. Negative 3 plus 5 also adds to 2. So these numbers are x minus 3 and x plus 5. Okay, again, I could switch the two numbers, but the negative sign has to stay with the 3. Okay, that is factoring a trinomial. So if I ever say like the words try, that's going to be more factoring like that. We also have what's called greatest common factor. So if I had 36x squared plus 12x, I would say, well, I don't have my last term that has no variable. So I'm going to use a different method, which is greatest common factor. That is looking at each of these numbers and saying, what's the highest number I can take out of both of them? So looking at 36 and 12, they both have factors of 2, of 12 is another huge one, 6 is 1. I go with the highest of all those factors, and it's 12. So I take out a 12. I also want to know what's the largest variable I can take out. In this case, I have an x squared and an x. The highest number I can take out is an x, because that's the lowest number I have. I can't take an x squared out of x, but I can take an x out of x squared. So how we figure out what's left over is whatever term we factored out, we divide each of these terms by said factor. So 36 divided by 12 is 3. X squared divided by x is x. 12x divided by 12x is 1. So I add on 1. That would be my most factored form. Let's do 3x plus 9. In this one, I'm going to go with numbers first. So 3 and 9. I can take a 3 out of both of those. Only one of these have a variable. This one does not. So I can't take a variable when I don't have one to take away. So I can only take out a 3, divide each of these terms by 3. I'm left with x plus 3. Let's do one more. 4x to the fourth plus 12x squared. So with this one, I look at factors of 4, factors of 12. 4 can come out. Also an x squared can come out. That's my lowest number, leaving me with x squared plus 3. Okay, and again, that's the most that I can take out here. Okay, one other thing I probably should bring up, back to factoring like a trinomial, x squared minus 16. So I'm saying it's like a trinomial because we're going to think about this as if it's the form of x squared plus 0x minus 16. It doesn't need to be equal to 0. I don't know how I did that. So how we factor trinomial again is two numbers that multiply to negative 16 but add to 0. So factors of 16, 1 and 16, 2 and 8, 4 and 4. One of these has to be negative in order to get to negative 16. If I do a negative 4 and a positive 4, that will work. So this is the one other form that you might see. All right, let's get into some of the actual problems here. Okay, there's a little factoring example for you. So I'm going to give you the following fraction. X squared minus 2x minus 3 all over x squared minus x minus 6. Okay, so again, first thing here, we have to factor these. I don't need to put an equal sign there. We cannot cancel, and I'm gonna see this all the time. If you have an x here and an x here, those cannot cancel. This x and this x cannot cancel. In order to cancel, you have to factor first. There has to be multiplication in between in order for you to factor. Okay, so thinking about factoring a trinomial, two things that multiply to negative 3 add to positive 2. That is going to be negative 3, positive 1. Negative 3 times 1, negative 3. Negative 3 plus 1, negative 2. And we have negative 6 multiplication, negative 1 addition, right? It's kind of like there's a little negative 1 here. So when I think about things that multiply to 3, I'm first struck with 2 and 3. So out of 2 and 3, which one of those needs to be negative in order for me to get to a negative 1? Negative 3 plus 2 is going to get me to a negative 1. Okay, so here's the fun part then. After I factor, that's when you get to say, like, yes, I finally get to simplify. So anything in your numerator can factor with something in your denominator. In this case, my x minus 3's are canceling, leaving me with x plus 1 over x plus 2 as a final answer there. Let's do one more of just simplifying. So we have 2x plus 2 over x squared plus 4x plus 3. Okay, so again, I want to factor both top and bottom. When I'm looking at my top, I'm only seeing greatest common factor. So I have to take a 2 out of both of these, leaving behind an x plus 2. Again, when you factor this, I take a 2 out, which means you're dividing each of these terms by 2, leaving me with x, oh shoot, sorry, it should be plus 1. My bad, totally my bad. Leaving me with x plus 1. It's a good thing I actually kind of worked that out there. Okay, so then on the bottom, factoring like a trinomial, so I know I should start this out with 2 sets of parentheses, x is in the front. Two things that multiply to 3, the only factors of 3 are 1 in itself. 1 plus 3 does add to 4, so my numbers are positive 1 and a positive 3 here. Okay, so again, the whole point is to simplify, so we want to cross anything out that we see on top and on bottom. X plus 1 and x plus 1 does cancel to leave me with 2 over x plus 3 as a final answer there. All right, now we're going to move on to multiplication. So when you multiply two fractions together, like a over b times c over d, we multiply straight across. There's no common denominators, there's none of that garbage, we just multiply straight across. We would take a times c and b times d. Okay, so in this next one, we actually don't have to factor. There's sometimes that you're given just one big term. 5x squared over 2xy squared times 6xy cubed over 10y. Okay, so looking at this, it looks super gross, and I'm not going to cancel anything yet. I'm going to wait to the very end, because if I start trying to cancel things, I'm going to have to cancel twice. I'm going to get everything smushed together and then try to cancel. So again, multiplying fractions is multiplying straight across. So when I go to multiply, I'm going to look for my like terms. Like terms are something like 5 and 6. So 5 times 6 equals 30. X times x squared. Remember, it's like there's a little 1 up top. When we have same bases, we add their exponent. So x times x, or x squared times x, is 2 plus 1, so x cubed. There's no y over here, so it's like having a 1. So x cubed, or y cubed times just a 1 is y cubed. 2 times 10 gives me 20. X times nothing over here, just a 1 is x. Y squared times y to the first is y cubed. Add those exponents. This is where I get to go ahead and start canceling some stuff out. I like to keep things all in a nice clean order. It doesn't matter what order you write these in though. It's all multiplication. Multiplication is commutative. So it doesn't matter how this is written as long as you have everything there that needs to be. Here I know I can take a 10 out of each of these. 20 divided by 10 is 2. 30 divided by 10 is 3. So coming to a final answer, I know I'm going to have a 3 over 2. Just like when we have same bases and we add their exponents when they're being multiplied, same bases here, you subtract exponents. So this x to the first cancels and takes 1 away from this, leaving an x squared. On this side, y cubed over y cubed cancels down to 1, which essentially just doesn't have to go because 3 times 1 is 3. So here, this would be your final answer. Okay, and I know it's my final answer because there's nothing else I can cancel out or cross out here. Let's do one more example of something like that. Let me make this one for my head. Let's have 7x squared y over 2x times 2x to the 4th y squared over x times y to the 6th. Okay, so we're solving this again, multiplying straight across. Multiplying like terms. 7 times 2 is 14. X squared times x to the 4th is x to the 6th. Y times y squared, y cubed. Adding those exponents, right? 2 plus 4 is 6. 1 plus 2 is 3. 2 times nothing over here. 2 times a 1 is just 2. X times x, x squared. I got no y's over here, so I'm just going to leave it y to the 6th. Okay, so again, I'm going to go ahead and start canceling. 14 over 2 cancels down to just a 7 over 1, or just totally 7. So far I know I'm going to have a 7. My x's here, I have 6 up top, 2 below. So these 2 below are gone. 6 minus 2 is 4, giving me x to the 4th. The next one though, my greater exponents in my denominator. So my numerator of y cubed is actually the one canceling, and I take 3 away from this 6 to get y cubed. So 7x to the fourth over y cubed is your final answer there. Again, if you need to see any of these problems for longer, feel free to pause, do whatever you need to. Since you have the ability to pause me, I'm not kind of hanging around waiting for you to write some of this stuff down. Okay, we are going to jump to some examples that involve factoring with multiplying these fractions. I'm trying not to make some of these, I'm trying to use some pre-made examples here, sorry. If I make these up on the spot, they might not cancel as beautifully as I want them to. Okay, so the first step in any multiplication problem when we have any of these fractions that have addition or subtraction in between is we know we're gonna have to factor before we can cancel. So I'm gonna go through and identify what ones of these need some factoring. Again, this is two terms being added. This is a greatest common factor. This is a trinomial. This is a trinomial. I cannot factor 3x, it's one term. So this is just gonna be left alone. So I'm looking through here, 3 plus 3x squared. Oh, this should be a 3x plus 3x squared. 3x plus 3x squared. What I can pull out of here is a 3x. What will be left over after dividing each of these by 3x? These cancel out to 1 plus x. Yeah, 1 plus x. Because 3's cancel, x squared divided by x is x. So once this one's factored, there we go. Factoring this one, two numbers that multiply to -5 but add to +4. Again, only numbers that multiply to 5 are 1 in itself, so 1 times 5. In order to get a +4, my 5 needs to be negative, and my 5 needs to be positive, my 1 needs to be negative. 5 times -1, -5. 5 plus -1, +4. Over here, when we are looking at factoring this, factors of 20, 1 and 20, 2 and 10, 4 and 5. So what can get me to a +1? That is a +1 value. It has to be two numbers that are only one digit apart. So it's got to be 4 and 5. If I want to stay positive, that 4 has to be what is negative. -4 plus 5 is going to give me that -1. Okay, and then in our denominator, again, we just still have 3x. So now, again, is the fun part. We got it all done. When we go to multiply these, you basically smush them all together, giving me 3x, 1 plus x, x minus 4, x plus 5, all over 3x, x minus 1, x plus 5. Okay, and like I said before, you can rearrange these terms all you want. When you're working with multiplication, that's okay. You can kind of flip-flop these all over the place. So I move the 3x out to the front of this multiplication. Because I see like, ooh, that 3x cancels. My x plus 5s cancel. But 1 plus x and x minus 1 is not the same thing. Because I have a -1 and a +1, which means that they're not going to cancel. So my leftover answer is 1 plus x times x minus 4 over x minus 1. Okay, after all of that, factoring, multiplying, trying to cancel out and simplify, that's what I'm left with. Okay, let's do one more example like that. All right. X plus 2 over no, that's not the one I want to do. Sorry about that. That is not the one I want to do. You know what? I actually think we're gonna have an okay time moving on. So because the fact that when we move on here to division, it's the exact same thing in one tiny added step in the beginning. So think about how we divide fractions. Okay, so this would be A over B divided by C over D. You can do one of two things. You can think about this as cross multiplying, or I think the easier way in this case is you do what's called keep it change it, flip it. So when we have A over B, that gets kept. Okay, so A over B stays. We change addition into multiplication. Now I'm multiplying the two. Additionally, C over D gets flipped. So now I'm multiplying it by D over C. So basically, you keep the first fraction, change multiplication to addition, and then flip the second fraction. So if I asked you to divide 7x by 2x minus 10, or sorry, 7x over 2x minus 10, all divided by x squared minus 6x, all over x squared minus 11x plus 30. First step I'll have you do is now notch factoring. First thing I want you to do is figure out what is this new function going to look like? What's my new operation here? What do I have going on now? So keep the first fraction, 7x over 2x minus 10. Change the division to multiplication. Flip the second fraction. So it's now x squared minus 11x plus 30 all over x squared minus 6x. Now it's the exact same problem we did before. See, tiny little first step to go to here, then exactly what we did before. So I want you to, 7x cannot be factored, so you leave that alone. This is greatest common factor, and factor in like a trinomial. So I would suggest at some point you're stopping this video and trying to factor these on your own. You will never be able to solve these if you cannot factor these. That's the hardest part about these. Like, we know how we can cancel, but trying to factor is definitely our hardest part here. So like I said, I'm leaving 7x alone. Looking at 2x minus 10, out of 2 and 10, I can pull out a 2. 2x divided by 2 is x. Negative 10 divided by 2 is negative 5. Now I multiplied by, I know I have x's out in front. Okay, then I have to think two numbers that multiply to positive 30 and add to negative 11. So here's the tricky part. We have positive for multiplication, negative for addition. So two negative numbers can multiply together to make a positive. Two negative numbers can add to make a negative. So both of these numbers I know are gonna have to be negative in order for me to get there. Because a positive times a positive will not give me negative 11. And then a negative with a positive will not give me positive 30. The two numbers you're going to choose here are 5 and 6. Okay, and that's just a process of finding all the factors of 30, deciding which one's going to get me to 11. And this will be that only one. Greatest common factor. First, we can pull out x, and that's the only thing we can pull out. There's no common factor with 6 and 1 besides 1, and pulling out a 1 is pointless. It's just the exact same thing. So x divided by x squared is x. Negative 6x divided by x is 6. So here's the thing. Once we multiply these, you just shove them together. So if you can see at this step, well, this is on bottom, this is on top. This x is on bottom, this x is on top. This 6 or x minus 6 and this x minus 6 will cancel. I'm okay if you don't do that step of shoving them all together. It's the exact same thing as this. This is the most simplified. I promise that you'll probably ever get one of these. You are down to just numbers of 7/2. Okay, so 7/2 would be that final answer here. Okay, I want to do one more. Just one more. Okay, this last one I want to do is x squared plus 4x minus 5 all over x plus 5 divided by x squared plus 6x plus 5. Okay, so hopefully you're already like, ooh, you were missing a part, aren't you? I'm not missing a part. When you think about any real number, they're all technically part of the rational number set. If I think about the number 5, that's technically written over 1. If you have a variable of x, it's technically written over 1. All numbers we have are essentially written over 1. So that means this entire function is actually written over 1. So we can think about it that way. So when we turn division into multiplication, we have to keep it. So keep x squared plus 4x minus 5 all over x plus 5. Change it to multiplication. Flip it to have 1 over x squared plus 6x plus 5. Now is when the factoring portion comes in. Okay, so again, 1 cannot be factored. X plus 5 cannot be factored. This is factoring like a trinomial and like a trinomial, okay? So if I'm thinking of two numbers multiplied to -5, add to +4, I think we've already done one very much like this. That is going to be -5 and, sorry, +5 and -1. +5 and -1. All over x plus 5 multiplied by 1 over, we gotta find two numbers that multiply to 5 and add to +6. But the only two numbers that multiply to 5 are 5 and 1. And luckily, those also add to 6. Okay, so again, I can start looking through here and I say, ooh, that cancels, that cancels. But many people want to say, oh, they cancel out with both of them. They don't. There's one up top and there's two on bottom. You can only cancel one with one or two with two. So if I only have one up top, only one gets to go away on bottom. Also, I have an x minus 1 and x plus 1. So those can't cancel either. So what you should be left with is x minus 1 over x plus 5 times x plus 1 as a final answer there. Okay, so a couple of different things here: simplifying, factoring, dividing, multiplying fractions, but all of them with that same kind of thought process of trying to get just as simplified as you possibly can, whether it's through addition, multiplication, just simplifying, trying to factor to do so. Yeah, thank you.